Hello friends, welcome to my channel Physics with Rakshit. In the present video, I will explain parallel transport of vector in flat as well as curved geometry along with geodesic deviation. So in the previous videos, I explained that general relativity uses curved geometry or non-Euclidean geometry, while quantum field theory uses Euclidean geometry or flat geometry. Both concepts, that is parallel transport of vector and geodesic deviation, are useful in understanding general relativity as well as quantum field theory. So let's start. Parallel transport of vector in flat geometry is possible by two vectors that begin parallel in flat geometry will always end parallel because normal distance between the two vectors remains always constant. That is why it is known as flat geometry. But in case of curved geometry, two vectors that begin parallel will not end parallel because of the curvature of given geometry or gravitational pull of considered object. Let me take two examples. In first example, consider two buildings having same height which are separated by few miles. If I throw two balls from the terrace of both buildings, they will begin parallel but may not end parallel because of the curvature of Earth's gravitational force or gravitational field. When they reach to the surface of Earth, they converges to the center of Earth because of the gravitational pull of Earth, and that is why certain amount of deviation is introduced between their distance, and that is known as geodesic deviation. Geodesic means shortest distance between 2 points, and deviation means certain amount of change in the considered procedure or considered phenomena. So in this case, in curvature geometry, geodesic deviation is introduced because of the gravitational pull of Earth. Second example is, consider a sphere and consider first point. Here I have drawn a loop and a tangential vector. This tangential vector travels its journey from the pole of the sphere. Thereafter, it goes to equator of the sphere. Thereafter, it will again goes to that pole by this loop. Here you will see that this tangential vector's direction is changing. Simultaneously, certain amount of angle is introduced because of the geodesic deviation and because of the curvature of sphere. In this case, deviation is theta is equal to 90 degree. Same tangential vector, but geodesic deviation, because of geodesic deviation, certain amount of angle is introduced. This is what is called curved geometry. So curved geometry is bit difficult to understand because of the mathematics and this kind of deviation. And geometry introduced several new notation, like Einstein also introduced in his general theory of relativity. Einstein took help of Riemannian geometry and Gauss geometry to explain his theories, that is general theory of relativity. So in general relativity, many concepts take help of these two concepts, that is parallel transport of vector in curved geometry and geodesic deviation. For example, various metrics like spatial metric, Bondi metric, Vaidya and many metrics are there. So this is the basic concept through which you can understand covariant derivative, Riemannian tensor, Einstein's field equation, and thereafter other important equation and other important concept of general theory of relativity. Thanks for listening. If you have any question, you can ask in the comment section. Thank you very much. If you like my channel, please subscribe my channel.